Okay, folks, this is on page 47, number 23. An example of some decision trees. So, first thing I want to do is say that we're deciding whether or not we want to have, we have two options. We can purchase one machine outright, or we can purchase two machines. If we do happen to purchase two machines or one machine, there's a couple of different things that can happen with the demand. So we can have high demand, and the probability of that occurring is 80%. Or we can have some low demand, and the probability of that is 20%. In this scenario, we're going to have the exact same options. Whether we put two machines in, we'll have high, and it'll be 80%, and low, and it'll be 20%. Now, what's interesting here is with this problem, we now have another decision that we can make, which is up here, and that's what happens when the demand is high and we only have one machine. A few different things. First thing we can do is always do nothing. Okay, so if we do nothing and we have one machine, our net present value for that is going to be $120,000. Okay. Second option is we can subcontract out. And if we do that, our net present value is going to be $160,000. Or we can, after only purchasing initially one machine, we can now purchase a second machine. And if we do that, our net present value is going to be $140,000. If demand is low and we have one machine, our net present value for everything is going to be $120,000, which coincidentally is the same as if we do nothing in the high demand. Down here with two machines, we're going to have a little bit different numbers. If we have two machines in high demand, we're going to have $180,000 net present value. And then for a low demand, we're going to have $90,000 if we have two machines. And this probably, likely, while not mentioned in the question, takes into consideration the fact that a machine would be underutilized, so on and so forth. So now this pretty much is how you would draw out the decision tree. Now we need to make the decision. So up here with the one machine in high demand, what we're going to do is we're just going to rule out some choices. We're not going to do nothing, and we're not going to do purchase a second machine, because the net present value of subcontracting out is the highest. So that's what we're going to use in our calculations. So if the demand is high and we have one machine and we've subcontracted out, a lot of ifs there, we're going to have our total net present value is going to be 80% of $160,000, which is going to give us $128,000. If the demand is low, then we're going to have our calculation is going to be times 120, and that's going to give us $24,000. Sum that up, so 128 plus 124, and we're going to have a net present value of $152,000 if we pick one machine. Down here, very similar, just the same kind of calculation, 0.8 times 180, and that's going to give us $144,000. Down here we're going to have 20% of 90, which is 18,000. which gives us our net present value of 2 machines is going to be equal to $162,000. So as I mentioned, when we finished drawing up the diagram before calculating the values, that was the decision tree part A. Now that we've calculated this out, we're making some statement about what we should do. And what we should do is actually purchase 2 machines because it gives us the best net present value. And that's how you do a decision tree.